All right, in this explainer, we are going to crack the code behind one of the most powerful illusions in art, in film, and yeah, even in the video games you play every single day. It's this incredible trick of spatial logic that organizes how we see and tells us exactly where we're supposed to look.
You know this shot. You've seen it 1,000 times. This long, perfectly symmetrical hallway, just pulling your eye towards a single faraway point. This, of course, is from Stanley Kubrick's The Shining, and it's an absolute masterclass in using space to create this deep feeling of dread.
So why? Why is this image so hypnotic, so unsettling? Why does it feel so inevitable? Well, the answer isn't just some clever camera work. It's actually a 600-year-old artistic technique that completely rewired how we show the world on a flat surface. To really get how big of a breakthrough this was, we first have to appreciate the problem they were facing. For centuries, artists struggled with this really fundamental challenge. How in the world do you create the illusion of a deep, three-dimensional world on a totally flat, two-dimensional canvas? See, before the Renaissance, art often looked, well, flat. And that's because it was playing by a completely different set of rules. The goal wasn't to capture what the eye actually sees, but to represent a more symbolic or spiritual order of things. Space was all conceptual, not optical. They had this system called hieratic scale, and what that meant was that a king or a saint was always, and I mean always, drawn bigger than a normal person, even if that person was supposed to be standing right in front of them. Your importance, not your location, decided how big you were.
So how did they solve this problem of flatness? Well, everything changed in Florence, right around the year 1420. An architect, a guy named Filippo Brunelleschi, he finally cracked the code. He transformed art from being this symbolic map into a rational, measurable space. He did it through this brilliant, kind of wild experiment that involved a painted panel, a mirror, and a little peephole. And with it, Brunelleschi proved that you could perfectly copy human vision using a mathematical system. This was it. This was the birth of linear perspective. But it was another guy, the theorist Leon Battista Alberti, who gave us the perfect metaphor for this new way of seeing. He said a painting should be like an open window. And this one idea, this is the key to understanding literally everything that comes next. So how does this open window actually work? Well, the entire system is built on just a few simple geometric rules. First, you start with the horizon line. This is always at your eye level as the viewer, and it immediately sets up your vantage point on the whole scene. Okay, next, you place one single point on that horizon line. This is the vanishing point, and it is the crucial anchor for the entire illusion. You can think of it as the infinity point, right? It's where all the parallel lines in the scene look like they're racing towards and just disappearing. And finally, you draw these lines that radiate out from that one vanishing point. These are your orthogonals. They act like an invisible grid that determines the scale and the position of every single object inside your window, and that is what creates that powerful, powerful illusion of depth. So when you put it all together, you can see how these simple parts create this complete logical system. The horizon line sets your height. The vanishing point pulls everything into the distance. And the orthogonals, well, they provide the tracks for it all to recede on. It's like a perfect visual engine. Now, armed with this new visual superpower, Renaissance artists didn't just start making more realistic paintings. No, they turned the canvas into a theater, a stage for telling complex stories and expressing some really profound ideas. Masaccio was one of the very first to truly master this technique. In his fresco, The Holy Trinity, the perspective is so perfect, especially when you look at that barrel vault ceiling, that people at the time said it felt like a hole had been punched right through the church wall. Incredible! And then you get Leonardo da Vinci, who uses perspective for pure psychological effect. In The Last Supper, every single one of those orthogonal lines, in the ceiling, the walls, the table, they all converge directly on the head of Jesus. So he isn't just the narrative center of the story, he's the literal geometric center of this universe. Okay, let's fast forward a few centuries, because this 600-year-old artistic rule is now one of the most powerful and common tools in the modern filmmaker's toolkit. And what's so fascinating is how the exact same technique, one-point perspective, can be used by two totally different directors, Stanley Kubrick and Wes Anderson, to create completely opposite emotional feelings. For Kubrick, this perfect mathematical symmetry feels inhuman. It's off.
It creates this too perfect order that feels super unsettling and menacing, and it pulls you down that hallway towards a danger that you just know you can't escape.
But then, for Wes Anderson, that same rigid symmetry feels charming and whimsical. His worlds feel like these perfectly arranged dioramas or doll houses. It's a signal that we're looking through a window into a meticulously crafted, almost fairy tale world.
And this same logic, it's not just for painters and directors, it's now the fundamental system behind the digital worlds we navigate every single day. Seriously, every time you explore a world in a video game, your computer's graphics card is basically doing Brunelleschi's perspective math millions of times a second to translate a 3D model into the 2D image that you see on your screen.
This whole thing happens inside a digital shape that has a kind of funny name, the viewing frustum. But all it really is the virtual camera's field of vision. It's this pyramid that defines what part of the 3D world gets projected onto your 2D screen. It is Alberti's window, just translated into code. So, we've traced this one really powerful idea, the picture as an open window, all the way from a Renaissance experiment to a tool for cinematic storytelling, and finally, to the core algorithm that builds our digital realities.
Which, it leaves us with a final thought. For 600 years, we've been looking at the world through Alberti's open window. But now, as new technologies like virtual and augmented reality start to show up, they promise to create totally new kinds of windows. So the question is, how will these new frames change the way we see reality itself?